Hello, welcome to Accounting with Mr. H. In this video, we're going to look at absorption costing and how to calculate OARs, overhead absorption rates, and then how to use those OARs to calculate the total cost of a product and the selling price of a product. Thank you if you've already subscribed. Please do subscribe if you're finding these videos useful. Like, share, comment. Let me know what you'd like to see in future videos. Here we go then. So quite a lot going on in this question. Let's have a bit of a look through the information. The following information is available for Bayside Limited for the year ending 31st December. And then the first table, I can see they've got three production departments, a cutting department, a machining department, and a finishing department. And I've been given some information about each department, the cost of the machinery in each department, the floor area in square meters, the direct labour hours and the direct machine hours used over the year in each department. I'm then being told the factory overheads are, so they've got rent, light and heat and machinery depreciation. And finally, the company makes two products. They make a product called palm and one called sand. And then in this second table, I've got some details about these two products, the direct materials that are used to make each product, the direct labour, the machine hours per unit, and the markup. And ultimately, what am I being asked to do? Calculate the selling price of each product using absorption costing. So there's quite a lot going to be going on in this question. But it will be useful to see most of the process, or the process of how we use absorption costing to calculate the cost of a product and then the selling price. So over on the right hand side, you'll see I've already laid out an overhead apportionment schedule. And this is the first thing I'm going to do. I'm going to need to find a way to apportion, which just means share out, the overhead. So those bullet points on the left hand side, the rent, the light and heat and the machinery depreciation, I need a way to share these out between each of the three departments. And absorption costing looks for what we call a basis of apportionment. And so ultimately, we're just trying to find the fairest thing to use from the information that we've been given, or the information that's available. So let's start with the rent then. So my first overhead is rent. And if I look at the table at the top, they've told me the cost of the machinery and the floor area. Well, out of those two, the fairest one to use to share out, to apportion the rent, would be the floor area. So my basis of apportionment is going to be floor area. And what I need to do then is a working to work out how much of the floor area to give to each department. So the total rent is £207,000. So you can see I've put that on the top of my formula. And then I'm dividing that by the total floor area of the company. So that's the 14,000 square meters from the cutting department, the 20,000 square meters, which is the size of the machining department, and the 12,000 square meters size of the finishing department. And that gives me £4.50 per square meter. So apportioning this rent then, I'm going to do it on the basis of floor area at a rate of £4.50 per square metre. And now all I've got to do is multiply it back again to each department. So the cutting department, we've got 14,000 square metres. That's how big that department is. So cutting department then 14,000 square metres at a rate of £4.50 rent per square metre. £63,000 has got to go to the cutting department. So that's the share of the rent that the cutting department is taking. And then I'm going to do the same logic for the machining department. You can see there gets us 90,000, and the finishing department 54,000. So I've now shared out the rent, that £207,000, in a fair way using the floor area. You can always do a quick double check, like is so often the case in accounting. If you add up the 63,000, the 90,000 and the 54,000, it should take you back to the 207,000, the total rent. Okay, let's go on to the next one. So the next thing we've been given, the next overhead is the light and the heat. I've just put L and H because I haven't quite got enough room here, trying to keep it all on one slide. So light and heat. And looking at the choices, so in this question, again, I've only been given the cost of machinery in the floor area. In another question, sometimes you get things like kilowatt hours. So you'd actually get the amount of power that's being used in each department. That might help with something like electricity. But for light and heat, out of the two, the fairest thing is going to be to use the floor area again. So basis floor area, working 2, and I'm going to do a similar thing to what we did for the rent. So this time though, I've put the total of the light and heat overhead on the top of the formula, £82,800, and then divided by the total floor area in square metres, so the 14, the 20 and the 12,000. And this tells me then that the light and heat needs to be apportioned, shared out at a rate of £1.80 per square metre. And then I'm going to do the same as we did before. So multiply it back into each department. So cutting department we know has 14,000 square metres times £1.80. So the cutting department needs to take £25,200 worth of the light and heat. And then the same for the machining department and the finishing department. There we go. Perhaps just worth noting at this point, why we are doing this. These are the overheads, so these are the indirect costs. These are the things that we can't assign to specific cost units. In other words, specific products. So the two products that this company makes, the palm and the sand, there isn't there's no way of saying, oh well, each palm needs to have this much rent. We've got to find a way of sharing it out, and this is how this business is doing it. They're using absorption costing. So an overhead apportionment schedule is used to share out the overheads or the indirect costs between each of the departments, and then we'll see in a little while how we can then build these into the cost of each unit. The last one then is the machinery depreciation. So let's get on to this one. Yeah, I've just put depreciation again, just I haven't quite got enough room here, but machinery depreciation. And this time though, I'm going to use the cost of machinery because that would seem the fairest thing to use. If we've got to share out the depreciation, well, the depreciation then is obviously reducing the cost of the machinery. So that would seem, from the information being given, the fairest basis. So cost of machinery, or cost of M, couldn't quite fit it in. And similarly then, so the machinery depreciation is £80,000. Let's get it working up, there we go. And divide by the, this time, the cost of machinery. So £40,000 is the cost of the machinery in the cutting department, 70,000 in machining and 18,000 in finishing. And you'll see that gives me then a rate of 62.5p. Sometimes in questions that it does end up with a halfpenny. If it is a halfpenny, then leave it at the halfpenny because normally when you then multiply things back, it cancels itself out again. So 62.5p then, and let's put it back in. So the cutting department, the cost of the machinery in the cutting department is £40,000. So 40,000 times 62.5p, 25,000. So let's put that there. There we go. And then same for machining department, and same for what was the last one? The finishing department, £11,250. And then the final thing I'm going to do to finish this first part of the answer is just to total up then the overheads that have been apportioned to each department. So cutting department, 63,000, add 25,200, add 25,000, gets us 113,200. Add up the machining, there we go, and the finishing. So I've now shared out, apportioned the overheads between each of the three production departments using the fairest basis of apportionment that I had available to use. Okay, the next thing I'm going to do then is now work out the overhead absorption rate, often abbreviated to the OAR, or the OARs. So we know, if I look at the cutting department, the cutting department has now absorbed a total of £113,200 of the overheads. but I can't put all of that on one product. I can't put all of that into the cost of one unit of the palm or the sand. So I need a way of absorbing that into each unit that is manufactured. And that's where the OAR comes in, because it's literally the rate at which we're going to absorb the overhead absorption rate, the OAR. And when it comes to OARs, we have a choice of two. We can either use the direct labour hour rate or the machine hour rate. And unless it tells you otherwise, it's a case of looking to see whether each department is what we call labour intensive or capital intensive. Put simply, does the department use more labour hours or machine hours? So if we look at the cutting department then, the table on the left-hand side tells me that in the cutting department in the year, they're using 20,000 direct labour hours and 12,000 machine hours. So this department uses more labour than it does machinery. So it is labour intensive. So that means I'm going to use the 20,000, the highest one. So the OR for the cutting department, you can see my working come up there, is the 113,200, the total overheads that have been apportioned to the cutting department, divided by the 20,000 hours, gives me an OAR of £5.66 per labour hour. Sometimes in a question it will say, why did you use that OAR? Well, it would simply be a case of saying that the labour hour OAR was used because the cutting department is labour intensive. In other words, it uses more labour hours than it does machine hours. Then I'm going to do the machining department, and if I look at the machining department, it uses 14,000 labour hours, 24,250 machine hours. So this department uses more machine hours, perhaps not surprising as it's the machining department. So this department is what we call capital intensive. So same idea, but this time using the machine hours. Overheads divided by 24,250 gives me then an OAR of £7 this time per machine hour. And then finally the finishing department, not much in it, but the labour hours is slightly higher than the machine hours. So back to labour then for this one, 17,370 labour hours. And that gives me then an OAR of £5 per labour hour. Right, and then we come near to the end of this question. You'll see I've just moved over the OARs that we've just calculated into that yellow box because I'm going to need to refer to them in a minute. So the final thing to do then is to actually work out the selling price of each product using absorption costing, using all of this information then that we've been working out. So the first thing I'm going to do is start with the direct costs. Remember, everything we've done up till now has been focused on the indirect costs, the overheads. So I'm going to leave those for a minute, come back to them in a minute, and I'm going to turn my attention to the direct costs. And if you look at the table on the left-hand side at the bottom, this is where it gives us some information then about the direct costs. So the palm, the direct costs, it says £8 per metre, and to make one palm, it requires 4 metres of this material. So the direct materials for a palm are 4 metres at £8 per metre, so that's going to cost £32. To make a unit of sand, they need 6.5 metres of this material, which costs £8 per metre, so that's going to cost 6.5 times 8, £52. Then I'm going to move on to the direct labour. So for palm, it takes 2 hours of direct labour, and that is at a rate of £16 per hour. So 2 times 16, that's £32 worth of direct labour. To make a unit of sand, it's 3.5 hours labour, £16 an hour. So 3.5 times 16 is going to cost £56. There's no other direct costs. Sometimes in a question you see royalties, manufacturing royalties, that would be a direct cost, but in this question that seems to be it. So I might just do a quick total here. The direct cost per unit, so 64 for the palm, £108 for the sand. Then what I'm going to do, I need to absorb a bit of the overheads into each unit. And this is really what the whole point of the absorption costing is. So we've got the direct cost, that's easy, but we needed a way to share out all of these overheads into each unit. And we've done it by apportioning and then working out the OR. And that yellow box then, this is what I'm now referring to. So the first thing I'm going to do is look at the cutting overhead. So basically, the cutting department has total overheads of £113,200. But we need to share that out between each unit that is manufactured. And we've worked out that we're going to do it at a rate of £5.66 per labour hour. So all I'm doing now is using that OR. So the cutting overhead, £5.66 per labour hour is the rate at which it's got to be absorbed, given, if you like, to each unit. So per labour hour, so ask yourself, how many labour hours does it take to make 1 unit of palm? And we can see in that table at the bottom, it's 2 labour hours. So if we're absorbing it at a rate of 5.66 per labour hour, well, there's 2 labour hours for a palm, so £5.66 times 2 means that each palm needs to absorb £11.32 of the cutting department's overheads. Then do the same for the sand, but the sand takes 3.5 labour hours, it says in the table at the bottom. So 3.5 hours times £5.66 gets me to £19.81. And then I'm just going to do the same for the others. So the machining department, this time we worked out is going to be absorbed at a rate of £7 per machine hour. So focus on the machine hours this time. So to make a palm, it takes 6 machine hours, it says in the table at the bottom left. So 6 machine hours to make 1 palm. We're absorbing the machine department's overheads at a rate of £7 per machine hour. So 7 times 6, the palm then needs to take on £42 of the machining overheads. And then to make a unit of sand, it only takes 2.5 machine hours, it says in the table. So 2.5 times 7, £17.50 is the amount to be absorbed by each unit of sand. And then finally, the finishing department, back to labour hours for this one. So £5 per labour hour is what our OR tells us to do. So the labour hour for a palm was 2 hours to make a palm, 2 labour hours. So 5 times 2, 10. And then the labour to make a sand is 3.5 hours. So 5 times 3.5, £17.50. Then what I might do here is just get a total cost per unit. So I'm now adding, so I've got the direct cost for a palm of £64. I'm just going to add on all of those overheads. So the 11.32, the 42 and the 10 gives me a total cost for 1 unit of palm, £127.32. Do the same for sand. So sand total cost using absorption costing, £162.81. And then finally, I can then work out the selling price. So the final bit of information I'm given over on the left-hand side is the markup. And it says they add a markup then on a palm of 50% and on a sand of 100%. So the markup then for a palm is going to be 50% of the total cost. So half of 127.32, which is 63.66. And then a sand, they add 100%, so they literally double it. So the cost is 162.81, so the markup will be 162.81. And then finally, then I'm at the answer to the question, the selling price per unit. So add the markup onto the total cost. So 1 unit of palm needs to sell then for £190.98, and each unit of sand needs to sell for £325.62. Quite a lot going on in that question. You wouldn't necessarily get all of that in one exam question, but hopefully it's been useful just to see all the process. So if you're faced with any of the stages, you can hopefully relate to what you need to do. I hope that's been helpful then. Please do subscribe, like, share, and comment. Let me know what you'd like to see in future videos.